Question 1. Use logarithm to solve the given equation, giving your answer correct to 3 decimal places. Okay, that's new. Okay, so the equation is this: e to the power x equal to 3x minus 2. So to get the values of x, they should first climb down, and they can't climb down anyhow. We'll have to do something, and which is apply log to both sides. Applying normal log base 10 will not help because this e will not go with that log. So we will use the other log with base e, ln. So let's apply ln to the both sides. Whenever we apply ln to e, they neutralize each other and we are just left with x. That is the advantage of using ln here. Here, this x minus 2 is the exponent. It will become the coefficient of ln 3. Now we have to club these two x's together so that we can find its value. So I will first open the bracket x ln 3 minus 2 ln 3. So I'll keep this number here but bring the x with the x. So x minus x ln 3 minus 2 ln 3, which is equal to minus 2 ln 3, and both of them have x's, so we will take x common. Nothing is left here, x is out, so 1 we will be writing 1 in place of x. This x is also out, so we are left with just ln 3 equal to minus 2 ln 3. I didn't write 3 here. Okay, so now x is alone. We will cross multiply. We'll just bring this whole thing to the right side. We can bring only the parts which are multiplying with the rest of the parts. So this whole thing is multiplying with x. That's why I can bring it down. Otherwise, if it's adding or subtracting, we have to add or subtract accordingly. 2 ln 3 divided by 1 minus ln 3. This is the value of x. Now we will use our calculators to find its value, and they're saying up to 3 decimal places. By the time I do this, I would request you to subscribe to my channel and like and share this video with your friends. I am solving these exams which are quite old, so that there is no chance that you don't get good quality solutions of past papers. So please share this video and subscribe to my channel. The answer I got with my calculator was 22.281. They said 3 decimal places. This is 3 decimal places. What's next? Question number 2 is next. Use the trapezium rule with 3 intervals, just 3 intervals, to estimate the value of this one, giving your answer correct to 2 decimal places. Alright, so we should first make a table where we will write x and then we will write cosecant x. And they said 3 intervals. So we will start with 2 over 3 pi. No, not 2 over 3 pi. 1 over 6 pi is the smaller one, right? So 1 over 6 pi. Now, one interval will be this one from here to here, second interval from here to here, and third interval from here to here. So we want to divide the distance between 1 over 6 pi till 2 over 3 pi in 3 intervals. Can you see? 3 intervals. So basically we will do 2 over 3 pi minus 1 over 6 pi. Whatever is the distance, we will divide it into 3 parts. So it becomes 4 over 6 minus 1 over 6. That becomes 3 over 6. Yeah, 3 over 6 pi divided by 3. So I can multiply by 1 over 3. This 3 and this 3 cancel out. So 1 over 6 pi is the width of one interval. So now 1 over 6, we will add 1 more over 6 because we got interval equal to 1 over 6. We will add 1 over 6 to this so that we get the next one, which will be 1 over 3 pi. Now we will add one more 1 over 6, we'll get 1 over 2 pi. And then when we add 1 over 6 more, we get 2 over 3 pi. So we got our 4 x values, and now one by one we will substitute in our calculator, but there is nothing called cosecant x in our calculator. What we will do, for example, for this one, we will put 1 over sine, because the reciprocal of sine is cosecant, and 1 over 6 pi. This we will put in our calculator. Whatever value we get, we will write here. Similarly for other three. So now I'm disconnecting this video, and when it resumes within seconds, you will see that this whole table is full. Now our table is complete. I have written decimal form in the ones which are in decimal, not the exact, because while drawing a graph or using trapezium, we use the y values on the graph sometimes. That's why I use decimals. There's no problem. So now, the trapezium formula is this, which will be given to you in exams, right? Let's try to see which one is which in this. So, first of all, we should have a function with limits a and b. We had one in the original question. Then we have to write trapezium rule, which is half h. Now, half h. What is h? H is the difference between two consecutive intervals, and we just found it. That was 1 over 6 pi. Remember, they have given here how to find h, which I did. B minus a. This was our b, this was our a, divided by how many intervals we want? 3, divided by 3. And that's how I got 1 over 6 pi. So in place of h, I will write 1 over 6 pi, or let me write pi over 6. It's the same thing. Then y0 is the first y value, which is 2. Then y value, the last one, I'm not writing it the last, this yn is the last, right? Let me write it in first only, 1.1547. I'm writing this is yn. The last one is called yn, the first one is called y0, plus 2, this 2. y1 is the next one, which is 1.1547, plus y2 is the next, which is 1. And that's it. We have just 2 between the first y0 and yn. So there's no need to go further than this. And this yn I wrote already in the starting. And close it. Just we have to put this in our calculator, and whatever value it gives us, we have to round it to 2 decimal places that they are asking. Let's use calculator to find that. When I used mine, I got 1.95, 2 decimal places. Okay, we have another part for this, which is this. Using a sketch of the graph y equal to cosecant x, explain whether the trapezium rule overestimates or underestimates the true value. First of all, we should understand what is overestimating, what is underestimating. If you know, the area under the curve is like this. If this is the curve and I want an area, this one, right? So trapezium, for trapezium, this line will be a straight line. Can you see? And then it becomes a trapezium. This extra area in trapezium overestimates the curve's area. And if the curve is like this, and I want to make a trapezium from here till here, can you see there is some area which is under the curve but not in trapezium. So here it overestimated because trapezium is bigger than the actual curve, and here curve is bigger than trapezium. So here we underestimate. That's what it means. So basically they are asking us to see whether we get a concave graph or convex graph, and accordingly we'll decide. So let's see how the graph of cosecant will look like. We have these values, 2, 1.547 and all that. Okay, so let's draw it here. So this is x, this is cosecant x. pi by 6 rather. Okay, so at pi by 6, what was the value of cosecant x? It was 2, and then 1.1547 at pi by 3. So let's say 2 at pi by 6. At pi by 3, 1.1547 here. Okay, next was pi by 2 when it was 1. I hope so. Here it is 1. At pi by 2, it was 1. At pi 2 pi by 3, it was again 1.547. So now look, this is the curve which is concave. Can you see? So if we draw a trapezium here, it will overestimate because it will give us an area more than the area under curve. This is the area under curve, and we are getting more area by the trapezium. That means it overestimates the area under curve. Next question is this. The polynomial ax cube bx square plus x plus 3, where a and b are constants, denoted by px. So we are naming it as px basically. It is given that 3x plus 1 is a factor of px. That means it will completely divide this. And that when px is divided by x minus 2, the remainder is 21. X minus 2 is not a factor of this, but it gives a remainder of 21. That is understood. Find the values of a and b. Very straightforward question. So in this question, what we can do, we can use remainder theorem. In remainder theorem, if we substitute the zeros of the factors, what do I mean by zeros of factors or roots? 3x plus 1, make it equal to 0. So that gives us 3x equal to minus 1 or x equal to minus 1 over 3. If the factor is 0, your polynomial will be 0 if we substitute its value here, right? So that's what I'm going to do now. So a 1 minus 1 over 3 cube plus b 1 over 3 minus square plus minus 1 over 3 plus 3 equal to 0. The remainder is 0. And let's simplify this and make an equation out of this. Minus a over 27, right? Yeah. Plus, this will remain plus because this minus will become positive because of square, BADMAS rule. So plus b over 9 minus 1 over 3 plus 3 equal to 0. Okay. I don't like these different kind of denominators. Let's get rid of denominators by multiplying by 27, the whole equation by 27. So because 9, 3 and 27, all of them divide 27, so we can do that. So if I multiply 27 with the first one, 27 and 27 cancel out, I'm left with minus a. Then 9 cancels with 27 gives us 3, so 3b. 3 cancels with 27 gives us 9, so minus 9. 27 times 3 will not cancel anything, it will be 81 equal to 0. So we are left with the equation minus a plus 3b plus 72 equal to 0. This is equation number 1 for us. Similarly, if I put x minus 2, 0, x minus 2, this is not a factor, but when I plug this 2 into this, the whole thing will become 0 and we'll be left with the remainder. And remainder is given to us, it's 21. And that's what remainder theorem says. If you substitute this 2 into the equation, we will get a remainder of 21. So what was the equation? Let me write again. Ax cube plus bx square plus x plus 3, and in this case the remainder will be 21. Let's see what equation it gives us. 8a plus 4b, this is 5 minus 21 when it comes to the left, so minus 16 equal to 0. All of them are multiples of 4. So let's divide the whole equation by 4. Just like we multiplied the whole equation by 27 previously, here we are dividing by the same number throughout. So it will be 2a plus b minus 4 equal to 0. And now let's see what can we do. Let me eliminate a. We will multiply this equation by 2 so that I get a minus 2a here, because 2 times minus a will be minus 2a. 2 times 3b will be 6b. 2 times 72 is 144 positive. So let's see after adding them. People usually subtract, but because they are already plus and minus opposite signs, so there's no need to subtract, just add them. 7b, and this will be 140. Alright, equal to 0. And now let's complete here. 7b equal to minus 140, and b will be minus 140 divided by 7, that is minus 220. And we have to find a as well. So let's use this equation to find a, this one. So minus a plus 3b, 3b is minus 20 now, plus 72 equal to 0. Minus a minus 60 plus 72 equal to 0, minus a plus 12 equal to 0, minus a equal to minus 12. Both cancel out. A is equal to 12. B was equal to 20, and that was the question. Find the value of A and B. Moving on. The parametric equations of a curve are this and this. Whenever we say parametric equation, x and y equations are separate. That's why they're called parametric equations. The domain is given from 0 to half pi. Show that dy over dx is sine t. So first we will find dy over dt. And how will we find that? We will differentiate this equation, which will be whenever we differentiate a trigonometric function with a power, the power comes in front first and it goes down by 1 on the given ratio. Then we multiply by the differentiation of the base of the function. Base of this 3 was tan t. So we will differentiate tan t. So it will be secant square t. And then further we multiply by the differentiation of the angle. Angle is just t, so its differentiation is just 1. So this is our dy over dt. Let's find dx over dt. That's how we find dy over dx in parametric equations, right? So this is, okay, let me rewrite this one. X equal to cos power minus 3 t. That's what I can write, and I will differentiate it now. Minus 3 cos, and it goes down by 1. It becomes minus 4 t multiplied by the differentiation of the base, which is cos t. What is the differentiation of base? Minus sine t. Then we multiply by the differentiation of the angle. Done. So if I make this negative positive, so our overall differentiation will be plus 3, because this minus and this minus multiply, they become plus 3. Sine t is with no exponent, but cos was with negative, it goes down. That's it. So this is our dx over dt. Now we will use chain rule. Dy over dx will be dy over dt multiplied by dt over dx. So dy over dt is 3 tan square t secant square t multiplied by dt over dx. We have dx over dt here. Since we want the reciprocal of this, we will reciprocate this one, which will be cos to the power 4t over 3 sine t. This 3 and this 3 we can cancel out, and let's see what is the target. We'll go according to the target, sine t. That means most of them will cancel out. So let's convert this tan square t into sine square t over cos square t, so that we are left with only sine and cos. Secant is reciprocal of cos, so it will be written as 1 over cos square t. Then we have cos to the power 4t already, and then sine t here. Now, there are total 4 causes here. Can you see? They're multiplying, so their exponents will add. They will become 4, and we already have 4 on top, so they cancel out. We are left with sine square t over sine t. And again, this one sine t will cancel with one of the sine t's, and we are finally left with sine t. This is what they wanted. And the next part says, hence, show that the equation of tangent to the curve at the point with parameter t is this. That means this is the general equation of the equation of tangent. So, equation of a tangent is y minus y1 equal to m x minus x1. So when it is t, what is our y1? This is, we want a specific point x1 and y1, and they have already given us the equation for x1 and y1, which are dependent on t. 1 over cos cube t and tan cube t. Okay. So this is tan cube t, 1 over cos cube t is x1. So we'll be left with x and y. They will not be changed because they are the journal x's and y's on the line. M is the gradient. Gradient is dy over dx. We just got a sine t. So we replaced everything except x and y, which are never replaced. We've replaced the gradient, x coordinate and y coordinate as given to us. And now we have to show that it is equal to this. So let me write y equal to, because they want y equal to. I'll take this tan cube to the other side, which becomes positive, equal, and then plus x multiplied with sine t becomes x sine t. And then we are left with minus 1 over cos plus sine over. This sine t will multiply with that also. Sine t over cos cube t. Now somehow I need to get this one. X sine t is already there. That means these two should be changed. And I see some scope here. Y equal to, let's write x sine t here and keep it aside. This tan, I will write now, tan cube t minus, can I break this cos cube into cos t and cos square t? Yeah, why? Because sine over cos, this thing will become tan t. This is not there anymore. I've broken it into two parts. So I can write there tan t, and the remainder is cosecant square t. So can I write it 1 over cosecant square t, this one alone, which will be secant square t, right? Y equal to x sine t. Let's take tan t common from these two. So tan t, did I write plus? No. Tan t, so what is left here? Tan square t. What is left here? Minus secant square t, because this tan t is already taken common. And tan square t minus secant square t is equal to minus 1. This is an identity, but if you want, I can show you how. So this tan square t can be written as, first let's write tan t. This secant square t can be written as secant square t minus 1. This is an identity given to you in formula sheet. Minus secant square t. This and this cancel. What are we left with? Minus 1. And what is written here now is x sine t minus tan t. Yeah, because tan t multiplied by only left term here minus 1 is minus tan t, and this is what they wanted us to stay with. Next, throughout this question, the use of calculator is not permitted. That means we have to show the evidence that everything is being done mentally. The complex number w and z is satisfy the relationship this one. Okay, given that z is this 1 plus I, find w giving your answer in the form of this which are real. Okay, so let's substitute the value of z into the w equation. W equal to z. Z is 1 plus I, and then plus I is extra. This z became 1 plus I, and then we have I. Then we have iz, I, and z is 1 plus I and plus 2. So this gives us what? 1 plus 2I. This gives us I plus I square and then plus 2. I square is actually minus 1. So what can we further write it as? Let me write here 1 minus 2I, 1 plus 2I over I minus 1 plus 2. Minus 1 and plus 2 will become plus 1. So I plus 1. Okay. Now this is W, but they don't want this format. They want x plus iy format, means there should not be any denominator. We'll have to rationalize it by multiplying by the conjugate. So I minus 1 will be the conjugate and I minus 1 here as well. So let's see what do we get by multiplying. 1 multiplied by I is I. 1 multiplied by minus 1 is minus 1. 2I multiplied by I is plus 2I square. And 2I multiplied by minus 1 minus 2I over. This one is A plus B, A minus B format. And the identity for A plus B, A minus B is A square minus B square. We'll use this one. So I square minus 1. Actually it is 1 square, but I'm writing just 1. Okay, so I minus 2I will be minus I. Okay, this minus 1 will remain minus 1, and this I square is minus 1. When it multiplies with 2, we get minus 2. Divided by, this is minus 1 again, I square, and minus 1. So it becomes minus 3. So minus 3 minus I over minus 2. So if we write them separate, it will be minus 3 over minus 2 minus I over minus 2. So they cancel out, they cancel out. So what are finally left with? 3 over 2 plus half I. You can write I half. You can write this one. This is x, this is y, and that is the format they wanted. X plus IY. Part 2. Given instead W is equal to Z, then W and Z are same. And the real part of Z is negative. Okay, real part of Z is negative. Find Z, giving your answer in the form of x plus iy, where the x and y are real. So let's do it. This is the original one. W equal to Z plus iz plus 2. W equal to Z plus iz plus 2. So now they're saying W is actually equal to Z. So in place of W, we will write again Z. And we have to evaluate Z, right? Let's see. Yes, find Z. So that means Z has to be there. W is gone. Z equal to Z plus I over iz plus 2. Let's cross multiply. So iz multiplied by Z will be iz square, then plus 2Z equal to Z plus I, right? Okay, so can I write, leaves I here and Z's on this side? Rather, let's collect all of them to the left. So iz square plus 2z minus I equal to 0, and that becomes a kind of quadratic complex equation. Plus z minus I equal to 0. And now to find z we can use quadratic formula. Minus b. So what is a, what is b, what is c? Let's see. So this I is a, plus 1 is b, and minus 1 is minus 1i rather. It is a constant. Minus I is c. Alright. So minus b plus minus square root b square minus 4ac over 2a. No c. Okay. So minus b. Minus b means minus 1. Plus minus square root b square, again 1 square, positive 1, right? Yeah, 1 square minus 4 a is I, and c is minus 1i, which is minus I basically, over 2 times a, 2 times I. Okay, so what will that be? Minus 1 plus minus square root 1 minus 4, this minus and this minus will become positive, 4i square over 2i. Okay, minus 1 remains minus 1 plus minus this minus I square is, this I square is minus 1, that makes it 1 minus 4, which is minus 3. The square root of minus 3, that means we have to convert to complex again. So minus 1 plus minus, we can write this as square root 3 times square root minus 1. That's how I can separate minus from 3 over 2i. And what does that give us? Minus 1 plus minus square root 3i. Yeah, so minus square root of minus 1 is I, imaginary number, over 2i. This is the value of z, but they want the format x plus iy. If you remember there, it is written that they again want this in a format of x plus iy written here. Okay, that means we have to rationalize the denominator again. We'll multiply it by 2i and 2i. So what do we get here? 2 times 2 is 4, I times I is I square, 4i square again. 2i times minus 1 will be minus 2i plus minus square root 3, and 2 times 3 will be 2 square root 3. So let me undo this, write it again, 2 square root 3. And I times I is I square again. Alright, I square is negative 1, so we'll convert them. Minus 2i plus minus 2 square root 3, and this minus 1 is not going to make any mistake, any changes to this rather. So my plus minus will become minus plus. So practically no change. But it will become minus 4 here because I square will be minus 1, minus 4. We can see 2 here, 2 here, and 2 here. Let's cancel out all the 2's. So what are we left with? This 2 is gone, this 2 is gone, this will be divided by 2. We are left with minus I plus minus square root 3 over minus 2. So let's separate the numerators, minus I over minus 2 plus minus square root 3 over minus 2. This minus again is not going to affect this plus minus because they will reverse the sequence, but again they will be plus and minus. But here it will get cancelled out. So what are we left with? I over 2 minus square root 3 over 2, and I ignored positive now. Why did I ignore positive? Because in the original question, let me show you again, they're saying that the real part is negative. Can you see here? The real part of z is negative. So that means the positive one we will ignore, negative one we will keep. In question 6, it is given that this definite integral is equal to 1 where a is greater than 1. Show that a is equal to, when we solve this definite integral, we should get this situation. That's what they're asking. So exp that means exponential of e, that means they could not write it that clearly, this one, because it would be a little complicated, so they have explained it here. All right, so we need to integrate this first and then we will substitute the limits. So our main question is to integrate ln 2x dx. We don't have a direct way of doing this, okay? So what we can do, we can multiply this by 1 in front, okay? So what will that do? That we can now integrate this by parts, because we have two parts, one algebraic part, one logarithmic part. And if we know our rule of Liet, log is assumed as a simple u and algebraic one will be the differentiated part of v, and our formula for u v prime, which is our question, this is u, this is v prime, right? For that is equal to uv minus u prime v. This is the transformed version of product rule. So since this is the format of our question, this will be our solution. For that, first we need u, and u is ready with us. U is the logarithmic part, which is ln 2x. So our solution will be ln 2x multiplied by v. But we have the differentiated part of v, which is 1. V prime is 1. So to get v, we will have to integrate both of them. So v will be, what is with respect to x, the different integration of 1, which it will be x. So v prime was 1, so v becomes x. So multiplied by, oh, it looks like x itself, so let's write multiplied by x. This is uv. Now we have to go to integration of minus integration of, let me separate this, okay, u prime. U is log 2x, so u prime will be the prime of log ln 2x. So the differentiation of ln 2x will be 1 over 2x multiplied by differentiation of what is inside ln, which is just 2. 2 and 2 cancel, again 1 over x. So 1 over x is u prime, and v is already known to us, which is x, and dx. X and x cancel. So we are left with, let's write x first. So it will become x ln 2x, so that we don't confuse between multiplication and where the ln is ending. Minus. Now we have only 1 left here. Integration of 1 is x and plus c. This is the integration of ln 2x, with which this 1 was added by us, and that provided us the integration. Now we will introduce our limits. X ln 2x rather, minus x plus c. Limits were from 1 to a, and they said that it is equal to 1. To evaluate this, we will substitute a and 1 by 1 into the integration we got. So a ln 2a minus a plus c. This is what we get when we substitute a. Minus, we'll substitute 1 now. 1 ln 2 times 1, which is 2, minus 1 plus c, and they said this is equal to 1. So let's simplify this. We get a ln 2a minus a plus c minus ln 2 minus 1, not minus 1, it is negative 1 here and negative 1. So it will become positive 1 and minus c equal to 1. C and C cancel out, and let's see what are they asking us to isolate in the main question. Okay, a equal to exponent something, that means ln a should be isolated. This has to be isolated, so we will leave it here, ln 2a, because this will convert the other part into exponential. That's why I'm isolating this. So this a goes to the other side, becomes positive. This ln 2 also goes to the other side, becomes positive. 1 goes to the right side, becomes negative 1, and we already had a 1 here. This one, this minus 1 and this 1 cancel out. Now we have to get rid of this a. We divided every object by a, so that this a cancels out, this a also cancel out, but nothing happens here. Okay, ln 2a equal to 1 here, plus ln 2 over a. Now we will remove this ln. When removed, this ln causes the other part to become the exponent of e, 1 plus ln 2 over a. This whole thing is exponent. That's why they did not give it in this format, because sometimes it confuses. But please keep in mind, this whole thing is the exponent. Now we have to get rid of this 2. We'll divide this by 2 and we will write half here. So 2 and 2 cancel, and finally we can see we have a equal to half e to the power 1 plus ln 2 over a, and that's what they wanted us to show. Yeah, let's go to the second part. Use the iterative formula. This one, they converted the equation we just got into iterative formula to determine a correct to 2 decimal places, give the results of each iteration to 4 decimal places. But the problem is that we don't know where to start. But we can get hint from the question itself. Let's go back to the question. Here they have said e is greater than 1. Secondly, to start with, it was ln 2x here. Can you see? Ln 2x. If x value is more than 1, it will be giving us some value. So we have some idea that answer will be more than 1. That's what we will use here. So more than 1, let's start with 2. 2 is the nearest number to 1. And let's see if we get our correct answer. So a n plus 1, which is 2, because we are starting with the first. So n is 1 for us, and 1 plus 1 becomes 2. So it becomes half e to the power 1 plus ln 2 divided by a n. A1 we are starting with is 2. So let's see what it gives us. By the time I put this in my calculator, I would request you to subscribe to my channel and motivate me to make more videos like this video, share with your friends, and get more quality videos like this in future too. Thank you very much. After using my calculator, I got 1.9221. The good news is that we are close, because 2 and 1.92 are very close. That means our assumption was okay. So let's continue with this number. A3 will be half e to power 1 plus ln 2 divided by 1.9221 now. This was 2 earlier. Now we will use A2 in place of this, and which gives us 1.9493. Okay, A4 will be half e to the power 1 plus ln 2 divided by 1.9493, and that gives us 1.9395. Let's continue. A5, 1 over 2 e to the power 1 plus ln 2 over 1.9395, and that gives us 1.9430, and stop. Why? Because they said correct to 2 decimal places. So round off the first one to 2 decimal places. It will be 1.92. This one will be 1.95. This will be 1.94, and again 1.94. The moment 2 consecutive solutions are same up to the decimal places they have stated, stop it, and that becomes your answer. Your answer is A equal to 1.94. We were lucky here that what our assumption was 2 was very near to 1.94. What if I would act stupid enough to decide to start with, say, A1 equal to 10, or say for that matter A1 equal to 100? If I would think that these are the numbers, what would happen in that case? So I'm pausing this video and reconnecting again, and I will tell you, if 10 was assumed and 100 was assumed, what would be the number I would get? And the number I got for A1 starting with 10, if in place of this 2 I would have started with 10, I got A2 equal to 1.456, very near to 1.94 again. And if I would have continued, I would end up again at 1.94, but after many attempts. I got here A5, maybe A7 or A8 would give me 1.94. In case of A1 equal to 100, I got A2 equal to 1.368. Again, very close to 1.94. So, does not matter. But, my experience with iterative formula is that their solutions are usually single digit, low, 1, 2, 3 maximum. So, always start with a small number. You will get close to it within few attempts. All right. Let's move on to the next one. In a certain country, the government charges tax on each liter of petrol sold to motorists. Okay, the revenue per year is R million dollars when the rate of tax is X dollars per liter. The variation R with X is modeled by this differential equation, all right, where R and X are taken to be continuous variable. They are changing. Okay, when X is 0.5, R is 16.8. All right, solve the differential equation and obtain an expression for R in terms of X. So we can see here dr and dx. That means we are having variation with respect to X and R both. So in such case, if we want to simplify or solve this differential equation, we collect R with dr and X with dx. Let me take care of this R. So dr over r, right? Cross multiply. R goes and becomes denominator to the other side, and dx goes and multiplies with 1 over x minus 0.57 dx. So now dx is with x. There is nothing, no r here. Dr is with r. There is no x here. They are separated, and the purpose is to integrate them individually, both sides. Dr over r, this integration will be ln r, equal to 1 over x. The integration of 1 over x will be same, ln x. Now minus 0.57, integration of that will be 0.57 x, and obviously c. To find c, we will use this fact they have given when x is 0.5. So I will write 0.5 here, minus 0.57, and ln 0.5, r is 16.8, ln 16.8, and then plus c. Everything is known to us except for c. So keep the c here and move everything to the left side. Ln 16.8 minus ln 0.5 plus 0.57 times this will be 0.285. Yeah, 0.285, half of this, 0.25. There's no need to combine them and use logarithmic laws. No problem. They are numbers. Just put them in a calculator and you'll get the value of c. Let me use mine. With my calculator, I got 3.799, which I am rounding off to 3.8. And let's write the equation now, which was this one with c. Ln r equal to ln x minus 0.57x plus 3.8. And what were they saying? Solve the differential equation and obtain an expression for r. Okay, not for ln r, r in terms of x, not ln x. Alright, that means we have to remove ln here. It will become e to the power. When we remove ln from one side, the other side becomes exponent of e. It will be ln x minus 0.57 x plus 3.8. So let's separate this from this. Whenever we have same, let's say e to the power a multiplied by e to the power b, we write this as e to the power a plus b, right? We add the exponents. So these are adding. These three terms are adding. Let's separate them so that I can get rid of this ln. So r equal to e to the power ln x times e to the power, let's write 3.8 first and minus 0.57 x later. There's no need to, rather we can separate this also. Let's separate. E to the power 3.8 will give us a number, e to the power minus 0.57x. So I separated all three of them and this was negative here, okay? So e and ln will neutralize each other, not cancel, but yeah, it is equal to x. So x multiplied by e to the power 3.8. If we use a calculator, I got 44.696, which is 44.7, and e to the power minus 0.57x. So let me write 44.7 first. X e to the power minus 0.57x. This is the expression where r is in terms of x. There is one more part to this, which is this. This model predicts that r cannot exceed a certain amount. Find this maximum value of r. Okay, we have to find the maximum value of r means maximum value of this one. It will be difficult to estimate it by using the graphs or something, because there is an algebraic part, there is an exponential part. So the combination of the two, the graph cannot be predicted. So what can we do to find maximum or minimum value? What do? We find the stationary point. So let's differentiate this dr with respect to dx. That will give us some value of x, which will give us a stationary point. So this 44.7 is constant. Write it as it is. Do not touch it. X and e to the power minus 5.7x. This can be differentiated by product rule. So x will be, if I differentiate x, it will be 1 e to the power minus 0.57 x plus x will not be touched, but we will differentiate e to the power minus 0.57 x, which is e to the power minus 0.57 x itself multiplied by the differentiation of the exponent, which is minus 0.57. All right, and close. Yes. So dr over dx equal to 44.7. Now these two terms have e to the power minus 0.57x, both of them. Let's take it also outside so that it becomes easier. What is left? 1 is left in the first part plus x, rather minus 0.57x. That is the second part. Let me write it. Minus 0.57x. This is the simplified version of the first line. Now we want dr over dx equal to 0 for maximum or minimum. Obviously they are asking maximum, right? They are asking maximum. That means we'll get only one, which will be maximum. If we get more than one, then we'll have to verify whether it's maximum or minimum. Okay, which is 44.7 e to the power minus 0.57x 1 minus 0.57x. Okay, so now either 44.7 is equal to 0. Is it possible? Not possible. It's not. It's a wrong statement, so this cannot be solution. E to the power minus 0.57 x is equal to 0. E to the power anything will never give you 0. That means this also does not give us any stationary point. Finally, we are left with 1 minus 0.57 x equal to 0. And yes, 1 equal to 0.57 x. Alright, so x equal to 1 over 0.57. This is the value of x that will give you obviously maximum, because this is the only one. It can't give you minimum because that is the question. So this is the x value, and let's find the value of r now when x is 1 over 0.57. Let's substitute it here. This is the equation, right, of r. 44.7 x 0.57x. Okay, so r equal to 44.7 x. X is 1 over 0.57. Yeah, e to the power minus 0.57x. 0.57. All right, they cancel out. E to the power minus 1. So let's put this thing in our calculator now. R equal to 44.7 divided by 0.57 multiplied by e to the power minus 1. Yeah. Let's put this in a calculator and we'll get the maximum value of R. By the time I do this, I would again request you to subscribe to my channel and motivate me to make more such videos. 87% of my viewers are not subscribed, and many of you comment that my channel is underrated, so it can become properly rated if you subscribe to my channel. Some idiotic YouTube channels get millions of subscribers. I can get some thousands. All right, when I used my calculator, I got 28.849, which we can round off to 28.8. This is the maximum value of R. Question number 8, part 1. By first expanding sine 2 theta plus theta, which is 3 theta, is equal to this. So we have to show this. We can use the formula, the other identity, which is sine A plus B equal to sine A cos B plus cos A sine B. In this case, A is 2 theta and B is theta, and that's what we will write. So sine A sine 2 theta, cos B cos theta, plus cos A sine B. It is nowhere near to what is written here. So what we can do, we can convert sine 2 theta and cos 2 theta into single thetas. The identity for sine 2 theta is 2 sine theta cos theta. And then we have a cos theta again. So let's write it. The identity for cos 2 theta, there are 3 of them. But we want sine cube. Can you see here? Sine cube. And how can we get sine cube? If this sine multiplies with sine square. And that's what I will choose. The identity that says cos 2 theta is 1 minus 2 sine square theta. This sine square theta will cause sine cube theta to happen. Alright. So cos and cos become cos square. So 2 sine theta cos square theta plus sine theta 1 multiplied by sine theta. Okay. Now minus 2 times sine square theta, and we are there, sine cube theta. We need more sine cube because this is just 2. So we can convert this cos square also into sine. So 2 sine theta remains 2 sine theta, but this can be written as 1 minus sine square theta plus sine theta minus 2 sine cube theta. So let's open this bracket now. 2 sine theta minus 2 sine cube theta. We got 1 plus sine theta minus 2 sine cube theta. 2 sine theta and sine theta, they give us 3 sine theta minus minus 2 and minus 2 minus 4 sine cube theta. This is what was the requirement. There's second part also and third part as well. Show that after making the substitution, this in this equation it can be written as sine 3 theta equal to 3 over 4. That means we'll take some hint from the first part later on. Let's substitute first. X cube, we'll make the cube of this one, so it will be 2 sine theta over square root 3 cube minus x 2 sine theta over square root 3 plus 1 over 6 square root 3 equal to 0. So now if I cube this, each part will be cubed because they are multiplying and dividing. 2 cube will be 8. Sine cube will be sine cube. Square root 3 cube will be, okay, let's write square root 3 cube for the time being, minus 2 sine theta over square root 3 and plus 1 over 6 square root 3 equal to 0. Now let's find the LCM of square root 3 cube, square root 3 and 6. Now let me evaluate square root 3. Can I write square root 3 cube as 3 times square root 3? These two together will become complete 3 and the third one will be like this. So now we will find the LCM of these three, which will be 6. Now what else do we need for this 3 square root 3 to become 6? Multiply by 2 over square root 3, right? That's how it will become 6. So 2 over square root 3, 8 and multiplied by 2 over square root 3 sine cube theta. So basically I multiplied the denominator by 2 square root 3, so I have to multiply the numerator also by 2 over square root 3 for the first one. Second, this is minus 2 sine theta. What should I multiply square root 3 to become 6? So square root 3 needs one more square root 3 to make complete 3 and then 2. That means 2 square root 3 is needed for this to become 6. So we'll multiply this by 2 square root 3 further. And since the other one has 6 already, the denominator, no need to touch it. Just square root 3 equal to 0. The advantage of this is that this 6 goes and multiplies with 0 becomes 0 and we are left with this one 16 over square root 3 sine cube theta minus 4, 2 times 2 is 4. 4 square root 3 and plus sine theta, right? Sine theta plus square root 3 equal to 0. Let's rewrite it so that we can take something in common. So 16 over square root 3 sine cube theta remains this, but I will divide this by square root 3 so that I can take that square root 3 common and multiply by square root 3 further. So 4 times square root 3 times square root 3 will be 12. And we have a new square root 3 down there. And let's take this minus this square root 3 to the right side because we don't want anything else. Sine cube and sine theta we want here. Okay, what can we take common in these two now? We can take 4 over square root 3 as common, right? Out of 16 over square root 3, 4 over square root 3 out, we are just left with 4 sine cube theta. Out of 12 over square root 3, 4 over square root 3 is out, so what is left? Minus 3 sine theta equal to minus square root 3. Let's get rid of this by multiplying by square root 3 over 4. So we'll multiply here also by square root 3 over 4, and that's why square root 3 will cancel with square root 3, 4 will cancel with 4, we can't done this. Alright, so 4 sine 3. Now if we compare with our expression there, okay, look there, it is exactly same, but 4 is negative and 3 is positive in this original one, which was equal to sine 3 theta. But the one we got down there, 4 is positive and 3 is negative. Look here, 4 is positive and 3 is negative. That means this is already cancelled. This can be written as minus sine 3 theta. Why? Because the signs are changed. Equal to square root 3 times square root 3 is complete 3 minus 3 over 4. Both are negative. Make them positive. Sine 3 theta is 3/4, and this is what they wanted us to show. Sine 3 theta is 3/4. Number 3. Hence, solve this equation. Solve this equation, which has been converted to sine 3 theta equal to 3 over 4. And have they given any? No, they have not given any domain. That means, or maybe in the first part, no, the first part was just an identity. So I don't know how many solutions they want, and let's try to do that. So 3 theta equal to sine inverse 3/4, right? It is positive. So let's say that this and this quadrant sign is positive. We'll get answer in these two quadrants. Since they have not specified the domains, we'll give these two answers. Let's put sine inverse 3/4 in our calculator and see. And the angle I got was 0.8481. So this will also be 0.8481. Okay, so let's find the respective values for this for theta. So first one, 3 theta 1 will be 0.8481 itself, because we start from 0, yeah, and go to the first line, which is our solution. This is the first line, so this becomes our answer. Let's say theta 1 is 0.8481 divided by 3, which will be 0.2827. This is theta 1, but they are not asking theta 1. As far as I remember, they are asking x. Hence, solve the equation. That means we have to find x, and this was x. Theta was not part of the equation, so we will substitute this theta with the answer I've got, 2 sine theta over square root 3. So it will be x equal to 2 sine theta. Theta is 0.2827 for us, over square root 3. And when I put this in my calculator, I got 0.3221. Let's see how many decimal places they are saying. 3 significant figures. That means 1 we can ignore. Alright, this is our first answer. Second answer, 3 theta 2 equal to this angle from 0 till this line, which is, this is pi, and 0.8481 less than pi. Pi minus 0.8481. 3 theta 2 is 2.2935. So theta 2 will be 2.2935 over 3, which is 0.7645. This is theta, and now again we will put this in the equation of x so that we get the value of x. 2 sine 0.7645 over square root 3. And when this is put in our calculator, we get 0.799, 3 significant figures. These are the two answers. They have not specified the domain. That's why I stopped here. Otherwise, we can get as many as we want. Bring on the next one, which is this. Number 9. Let fx equal to this rational function. Express fx in partial fractions. So x square minus 8x plus 9 over 1 minus x 2 minus x square will be assumed as, for partial fraction, a over 1 minus x plus b over 2 minus x plus c over 2 minus x square. Whenever we have a square, once we write it without a square, once we write it with a square. So since the denominator will be exactly same as this left side, ignore it. We'll just focus on the numerator. So x square minus 8x plus 9 on left side. On right side we'll have a. It has 1 minus x with it, so that means it needs 2 minus x square plus b. It has 2 minus x, 1 power here, that means it needs 1 minus x as well as 1 of 2 minus x. And c, since it has a square under its denominator, it will be just requiring 1 minus x to have same LCM or denominator as other two. Alright, so now to evaluate a, b and c, we'll assume x equal to 1 so that this one becomes 0 as well as this. So let's put 1. 1 square plus minus 8 times 1 plus 9 on the left side. A equal to 2 minus 1 square. This will become 0, so we will not write it. This will become 0. We will not write it. Okay. So 1 minus 8 is minus 7 plus 9 is 2. Okay. And 2 minus 1 is 1. 1 square will be 1. So 1a. Just a. A is 2. Found it. Let's assume x equal to 2. Right? So that this becomes 0 as well as this becomes 0. So we'll be left with only this. So the left side, 2 square minus 8 times 2 plus 9. Right? Since this is 0 now, this is 0 now, so we will not write a and b, only c. C will be 1 minus 2. 1 minus 2. So it will be minus c here. And here, 4 minus 16 minus 12 plus 9 minus 3. So C is 3. What is left? B. For B, let's compare the constants. Compare the constant. So we have 9 on the left. So we'll write 9 on the left. What constant we'll get with A? 2 square, 4. So it will become 4a. What constant will I get from this? 1 multiplied by 2. 2b. Others will have x, so I'm not focusing on them. What constant will get here? C times 1c. So we know a and c already. Let's put those values here. 9 equal to 4 times 2 plus 2b plus 3. So what does that give us? 8 plus 3, 11. 9 minus 11 equal to 2b minus 2 equal to 2b. So b becomes minus 2 over 2 minus 1. This is b. So our partial fraction finally becomes what? A partial fraction. A is 2. 2 over 1 minus x plus b. We got minus 1 just now. Minus 1 over 2 minus x. And c is 3 over 2 minus x squared. This is the partial fraction. What next? Hence, obtain the expansion of fx, which we got just now, in ascending powers of x up to x square. That means we'll need this formula, which is on your formula sheet. So what can we write them as? It will be 2, 1 minus x to the power minus 1, minus 1, 2 minus x to the power minus 1 plus 3, 2 minus x to the power minus 2. I transformed the partial fraction I got in part 1 into this, and there we will apply this because now they resemble this particular left side. So let's do one by one and we'll stop at x squared. That's what they're saying, up to x squared only. So 2 remains 2 in first one, 1 minus x to the power minus 1. So it will 1 minus x, not plus x. So that means in place of this x, we'll write minus x. That's it. 1 plus n. N is the exponent, minus 1 in this case. Minus 1, x. X is minus x, not x. Plus n, n minus 1. So minus 1 will be minus 2. Divided by 2 factorial. And x square is minus x square whole. And stop, because they're saying up to x square only. Let's go to second one. But the problem with second one, if you can see here, is it has 2. Whereas our formula has 1. It must have 1 here. So we can do what? We can divide this by 2. Divide this by 2. And to compensate that, we'll multiply it outside by 2 to the power minus 1, because this minus 1, when this 2 comes out, it comes out with the exponent. So 2 to the power minus 1. This is what it will be now. So we'll write 2 to the power minus 1, which will be 1 over 2 by the way. But I will write 2 to the power minus 1 only. We'll take care of that later. Now 2 over 2 is 1. So our new, this thing becomes 1 minus x over 2 to the power minus 1, and now in place of x we have x over 2. Okay, so or rather minus x over 2. So I'll use the same formula, 1 plus n, n is minus 1 again, and then we have minus x over 2 plus minus 1 again, minus 2 again, 2 factorial again, but minus x over 2 to the power 2, and we'll stop because we have to finish at x squared. Now the third one, plus 3. Now again we'll divide this by 2 to make it 1, divided by 2, and this time because it's power minus 2, we'll multiply this by 2 to the power minus 2. 3 multiplied by 2 to the power minus 2 is out. 2 and 2 cancel, we are left with 1 now. 1 plus n, this time n is minus 2. X is not x, it is again minus x over 2. Plus n, n minus 2, this time minus 3 over 2 factorial, and minus x over 2 square, and done. Let's expand them individually and we'll get our answers now. So 2 is 2. 1 and this will become plus x, 1 plus x. This minus 1 and minus 2 will multiply and give us plus 2, and 2 factorial is also 2, they cancel out. This square will make minus x as positive x square, so plus x square, close. Now minus and 2 to the power minus 1 I will write as half, because to make it positive it will reciprocate it. 1, this negative and negative positive again, x over 2. Then here again they cancel out just like the previous part, and it becomes x square over 4. Now here we left with plus 3 over 2 square, which is 4. 3 times 2 to the power minus 2 becomes 3/4. We have 1 here, plus x over 2 again. Rather, this 2 and this 2 can cancel. So not x over 2, just x. Because this and this cancel, negative and negative become positive, we are left with just x. Now this and this will be again positive. Minus 3 times minus 2 will be 6. And 2 factorial is 2. 6 divided by 2 is 3. So plus 3, and this negative will be positive because of this square. So it will be 3x square over 4 closed. And now we'll combine x's, constants, and x square. So 2 times 1 is 2. Minus half times 1 is minus half. 3/4 times 1 is 3/4. So this is your constant part. Next, 2 times x is 2x. Minus half times x over 2 will be minus x over 4. Minus, rather, 3/4 times x will be 3/4 x. What about x square? 2 times x square is 2x square, positive. Minus half times x square over 4 will be minus x square over 8, x square, not 4. Alright, and 3/4 times 3/4 x square will be plus 9 over 16 x square. Okay, 2 3/4 minus half will be 2 1/4, which is 9 over 4, right? Yes. You can use your calculator. I'm doing mentally. Please use your calculator. So it will be 2 minus half, 1 plus 2 1/4, which will be 9 over 4. Oh, very good. 2 minus 1/4 plus 3/4, which will be 2 and half, which is 5 over 2. 2 minus 1/8 plus 9/16, so it will be 7 and 32, 39 over 16 x square. This will be the final expansion. 10th and last question is this. The line L has equation this. The point A has a position vector, this one. Show that the length of the perpendicular from A to L is 15. Let's try to visualize this first. That we have a line L. Its equation is 4i minus 9j plus 9k plus lambda minus 2i plus j minus 2k. A is somewhere, which is the position vector has, means somewhere is origin. From origin to this, the position vector is 3i plus 8j plus 5k. The position vector, whatever is the position vector, becomes the coordinates of the head of that point. That means the coordinates of this point are 3, 8 and 5. From this point, we want a perpendicular on line L, and they want us to show that the length of this perpendicular from A to L, wherever it is meeting, is 15 units. So let's assume one point M, let's call it M, and its coordinates as ABC. Let's assume that ABC is the foot of the perpendicular from A to on the line L. Since this ABC is on this line L, it will satisfy the equation of L. That means for some parameter lambda, A, the x coordinate, will be 4 minus 2 lambda. I'm not writing I because for point we don't need I. Okay. Now B will be minus 9 plus lambda, and C will be 9 minus 2 lambda. These are the coordinates in terms of the parameter lambda. Somehow if we find lambda, we will find the coordinates of M. So can I say that the vector L has this direction, right? So this is the vector of L, we can say, and we can say that minus 2i plus j minus 2k, which is the vector of L, if I dot product this with AM vector, this vector AM, the dot product will be 0 because we know this is a perpendicular, AM is perpendicular on line L. right? And let's find the vector MAM now, because we know the coordinates of A, we know the vector coordinates of M now in terms of lambda. So AM will be the position vector OM minus position vector OA, right? OM, whatever are the coordinates of ABC becomes the OM, which is 4 minus 2 lambda. So let's write here 4 minus 2 lambda I plus minus 9 plus lambda j plus 9 minus 2 lambda k. That is OM minus OA is given already to us 3i plus 8j plus 5k. Alright, so we'll find AM now. AM will be 4 minus 2 lambda minus 3, because both of them are i's. So we can subtract I from I only. We can't mix I, j and k. So 4 minus 2 lambda is already there, and we'll subtract minus 3 from it. Or rather, I should have put a bracket here so that these 8j and 5k are also subtracted I. Alright. Then what else do we have? 9 plus minus 9 plus lambda minus 8 j plus 9 minus 2 lambda minus 5k. Okay, so let's simplify this. So vector AM is 4 minus 3 is 1 minus 2 lambda I minus 9 minus 8 is minus 17. So plus minus 17 plus lambda j plus 9 minus 5 is 4. 4 minus 2 lambda k. And now we know that the dot product of this vector with vector of L is 0. So now I'll substitute this AM by its vector value. So it will be how much? Minus 2i plus j minus 2k dot 1 minus 2i 2 lambda rather I plus minus 17 plus lambda j plus 4 minus 2 lambda k, and this is equal to 0. The dot product is 0. To find the dot product of two vectors, we multiply the coefficients of I with coefficient of I. That means minus 2 multiplied by 1 minus 2 lambda, and i's are not written because the angle between I and I is 0, and if we know the dot product is this cos theta, right? In place of theta, if I write 0, it is 1. So we just multiply the magnitudes of the two vectors, and the magnitude of two vectors are the ones which are written in front of i's. So that's why I'm not writing I, and I will not write j as well. So 1, the coefficient of j is 1 multiplied by minus 17 plus lambda plus minus 2 times 4 minus 2 lambda equal to 0, and this will give us the lambda. So let's open the everything. Minus 2 plus 4 lambda minus 17 plus lambda minus 8 plus 4 lambda equal to 0. 4 lambda plus 4 lambda is 8 plus lambda 9 lambda minus 2 minus 17 minus 19 minus 8 minus 27 equal to 0. 9 lambda is 27, so lambda comes out to be 27 over 9, which is 3. And now we will find AM by just plugging in value of lambda in this one, and we'll get the vector AM. Let me write here. What does vector AM become now? It becomes 1 minus 2 times 3, because lambda is 3 now. So 1 minus 6 minus 5i. Minus 17 plus 3 minus 14, j. 4 minus 2 times 3, 6. 4 minus 6 is minus 2, k. I did it mentally, you can use your calculator, but yeah, every time lambda equal to 3 you have to put and you'll get am. But remember, what was the original question? Find the perpendicular distance, the length of am they are asking, that means magnitude of am. So magnitude of am now will be square root minus 5 square plus minus 14 square plus minus 2 square, which will be 25 plus 1, 96 plus 4, which is square root 225, which is 15. And yes, that's what they were saying. Show that this length is 15. I've shown that. I'm not doing the second part of this question because in 2022 the plane is not part of the curriculum anymore, so I'm not solving the second part.